All right. I challenge thee to determine how fast a rock was thrown off of a cliff. As long as it was thrown perfectly horizontally and it discovered to land 60 meters away. Now, if the cliff is 100 meters high, how fast was it thrown? Ooh. All right, so solve that problem, and I'll get back to you guys in the answer. So pause the video, get some work on it. Once you think you got it, unpause it, and we shall discover the secrets. All right, the answer is 13.28 meters per second. That's how fast that thing was thrown. Not meters, that's a distance. So let's see how I got that. First of all, you need a really good picture. All right, so always make sure you got a good picture. So here's my sketch that I did. Hidden behind door number 1 there's my sketch. All right, so I knew it's vertical displacement, I knew it's horizontal displacement, and I knew it was thrown perfectly horizontally, which is really important because that means that my initial velocity in the y-plane is going to be 0. All right, so speaking of initial velocities, and also known as, I'm certain that, I bet that's all my givens. Did you do your givens? I did mine. That's very important. Make sure you keep your x's separate than your y's. And so I list out them. X, I do not know the velocity. It is purely in the x-plane. I do know the displacement. I don't know the time, so it's unsolvable with the x. But if I look to the y's, my initial velocity is 0 because this is perfectly horizontally. There's no angle whatsoever. There's no y piece to this. It's in free fall, so our acceleration is negative 9.8. It's plummeting to its death, so our vertical displacement is negative 100, not a positive. And so I can use this to solve for time, because if I know time, what had just happened there? If I know time, then I can solve and put it over here, and apparently just highlight everything as I go. C'est la vie. So, I'll go away. So let's see. I got to solve for time. So to use that, I got to use a kinematic equation. So I'm going to use my y-plane over here. So let's bust out the old kinematics equations, subbing and solving. So I'm going to use delta y equals v sub naught delta t plus 1/2 at squared. Yep, it's your favorite and mine. Now this becomes a little easier because our initial velocity is 0, so that all goes away. And so now we just have to solve for t. You will get, it's square root, so it could be positive or negative, but we can't go back in time. So we got to solve for that time. Once you have that time, we can put it over here in the x-plane. And the x-plane, we're traveling at constant velocity because remember, if you were to draw a force diagram of this, anywhere along its path, the only force acting on it is gravity. So that means in the x-plane we have constant velocity, the y-plane constant acceleration. So since we have constant velocity, the only equation that's going to work for us is that of constant velocity. So v equals delta x over delta t. We know our delta x. We just solved for time up here, so we can bring that down there. Solve for Vx, and you get your 13.28 meters per second. So that's how fast it must have been thrown, which is about 30 some miles an hour. So yeah, pretty fast. All right. So hopefully that worked for you. Hopefully that makes some projectile sense, especially with purely horizontal launches. And I'll see you with the next physics problem.